Yo, welcome to another nostalgic math chat. We are inside IEB May 2023 paper 2, and today we're looking at question 7. So let's get into it. In the diagram, AC is the diameter of the circle with center O. Okay, so I'm just going to highlight that for myself. So told it's a diameter, so right, nice. Okay, so I'm already seeing some angles in a semicircle. I'm not seeing any radii other than AO. So yeah, those are just some things that immediately stand out for me. Right, we're told that BD is a chord of the circle, so nothing interesting there. I mean, there's a couple more chords. I don't see anything that's specifically special about BD. We've got BC, we've got CD, we've got AD, we've got AB. AB, CD is a cyclic chord, so that's just kind of nice to keep in the corner of our minds type of situation. Anyway, then we're told that B1 is 67.5 degrees. Okay, so I'm just going to fill that in. So that is 67.5 degrees. Yeah. And who else? C1 is 45 degrees. 45 degrees. Right. And then the question we are asked is triangle ABC an isosceles triangle? Okay, so it's just ABC, this guy. Is that an isosceles triangle? Isosceles triangle has two equal sides, which means it has two equal angles. So if we can show that two of the angles in triangle ABC are equal, then we've shown that it is an isosceles triangle. And on the other hand, if we show that there isn't two equal angles in the triangle, then we've shown that it's not an isosceles triangle. So I can immediately see that it is isosceles because in my mind I was already eyeing that, well, these two angles are 90 degrees, right? Because angles in a semicircle. So because angle B is a 90 and this one is a 45, then that means this one is also a 45. So then that means that side AB and side BC are equal, and therefore it's isosceles. So let's write that down nicely. Okay, so we're going to say, I'm kind of getting over this orange. Let's do a different color. So we're going to say angle B is equal to 90 degrees, and that's because angles in a semicircle right? And then we know that 90 degrees plus 45 degrees plus angle A1 is equal to 180 degrees, and that's because of the angle sum of triangle ABC. And so A1 is equal to 180 degrees minus 135 degrees, because that's what this adds up to, which is equal to 45 degrees. And so since angle A1 is equal to angle C1, then triangle ABC is isosceles. Whoa, isosceles. Okay, cool. Right, and then let's look at what we're asked next. Well, first off, I'm just going to highlight what we highlighted in the past questions. So, well, yeah. So this is a diameter, and then we were told that B1 is 67.5 degrees, and C1 is 45 degrees, and we have just uncovered that A1 is also 45, and that this is then equal to that side. Well, we haven't really justified that yet, but we kind of know that in the back of our minds. So we are asked to prove that angle A1, this guy, is equal to 2 times angle A2. Okay, so A1 is double the size of A2. Right, so we need to show that this guy is half of 45 degrees. Okay, or we can just determine what the size of A2 is and show that it's half of 45. Okay, cool. So let's see if there's anything immediately what springs out at me. Okay, is that okay? Well, I'm always curious about what chord does this angle A2 come from, right? Because I know the size of angle A1, so really the mystery here is angle A2. So which chord is it being subtended by, right? So if I follow A2 back to its roots, right, we can see that, okay, that's the one arm of the angle, and that's the other arm of the angle. So it is coming from the chord CD, right? And then the question is, which other angle does the chord CD subtend? At the circumference, at the center, and I can see that it is subtending the angle B2 at the circumference. And so that means angle A2 is equal to angle B2. And that's significant because previously we already showed that this angle over here is a right angle, right? So then that means I can work out what the size of that guy is, which means I then know what the size of that guy is. Okay, so let's write all of that down nicely. So we said angle A2 is equal to angle B2 because angles in same segment right? And then we said 67.5 degrees plus B2 is equal to 90 because angle in semicircle, so therefore angle B2 is equal to 90 minus that, which is 22.5, and so therefore A2 is equal to 45, not 45, is equal to B2, which is 22.5 degrees. And so we've shown that angle A1 is equal to 2 times, well, so how would we show this rather? So we would say, okay, since angle A1 is equal to 45 degrees, right, which we shown in question A, all right, and 2 times A2 is equal to 2 times 22.5, which is equal to 45 degrees. Then we have successfully shown that A1 is equal to 2 times A2. Right, so that's that on that.